3, so 3, 2, 1, and then when I say Lego, that's when you press go. All right? So 3, 2, 1, Lego. We've got a really big robot here. When we get down to 10 seconds, you guys are all going to count with us, right? There's plenty of time. Yeah, we got the ball game going. One ball.
Lego.
Hello, we are the Blazin Bots. For this year's research project, we have focused on the independence part of the Senior Solutions theme and have designed a product we call FLL. Each year, 1 in every 3 adults age 65 and older falls, with falls being the leading cause of injury and death for this age group. Our mentor and inspiration for our project, Bill Wegman, fell in June. He tripped over a curb, broke his hip, and is having a long, slow recovery. Over 95% of hip fractures are caused by falls, with 271,000 happening in 2009 alone. Mr. Wegman is aged 85 and lives in the Merrill Gardens retirement community. He was a mechanical engineer before he retired. It was much easier for him to get around before his accident, and he is not sure how long a full recovery is going to take.
After hearing about Mr. Wegman's fall, our team brainstormed ideas that we could use to prevent people from falling and came up with the idea of using sensors to alert them of things they may fall over. We talked to many different experts on sensor technology, including Dr. James McClellan from Georgia Tech. He is the chair of the Digital Signal Processing Group, and we talked to him about the different types of sensors we could use. We also talked to Dr. Jay Raman from the School of Polymer Textile and Fiber Engineering. Dr. Jay Raman designed a t-shirt embedded with sensors that monitor vital signs called the Smart Shirt. We talked to him about making our sensors easier to use and putting them in everyday accessories. We also researched other companies that create glasses with cameras and hearing aids, as well as other related technologies.
By far the most common way to prevent falls today is to use canes and walkers, including electronic canes that can detect some obstacles. Other common ways include having a person help support you while you walk and animal assistance. New research ideas include things like exoskeletons to help support you and keep your balance. There are also exercises that people can do to improve their strength, coordination, and balance, but most of the seniors we talk to at Merrill Gardens rarely exercise.
We call our solution for helping to prevent seniors from falling Baltimore. Baltimore consists of different accessories containing ultrasonic sensors and cameras to detect curbs, steps, and terrain changes, along with accessories that can notify the senior about potential hazards. We built a prototype with the shoe containing an ultrasonic sensor in the toe as well as front and side cameras. As you can see with this prototype, when the ultrasonic sensor moves closer to an obstacle, it lights up. In a real Baltimore product, all of the sensors, the processing of the signals, and the batteries would be in the sole of a special shoe or in an overshoe you could put on your own shoe. The message about the hazard could be sent to a hearing aid or to a wireless headset as a tone or verbal warning. All of our accessories would have battery packs that could be charged using recharging pads like many cell phones use today. Here is a short video that shows how our cameras and ultrasonic sensors would detect stairs and alert the wearer.
Stair climbing. Step. 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 Side view. Stair to left.
This video first showed our cameras and ultrasonic sensors detecting stairs up to the front, then detecting a step down to the left and alerting the wearer.
The innovations of FLL include putting sensors in accessories that seniors already use daily. We would use multiple sensors with computer processing to accurately detect the position of obstacles without having many false positives. Multiple sensors also help FLL work well in a variety of conditions, including day, night, sun, rain, snow, and mud.
To help us determine a manufacturing cost for Baltimore, we looked at some similar products. Companies like Nike are already beginning to put simplistic pedometers into their shoes. Also, devices like iPads, iPods, iPhones, and Kindles have sensors similar to the ones that we use at Baltimore. Recent cost estimates for an iPad mini are between $190 to $250. Another similar product, the Google Nexus 7 tablet, has a manufacturing cost estimate of between $150 to $175. Both of these cost estimates include things not used in Baltimore, like a rotation sensor, display, and high-end computer processing. As you can see, Baltimore would be more cheaply manufactured. We presented our ideas to our mentor Bill Wegman as well as other residents and employees at Merrill Gardens. We also discussed our research project in robot to our classmates at some of our schools. We plan to talk with the Home Lab group at Georgia Tech about how to make a more realistic untested and real environment. Thank you for your time. Do you have any questions how Fall No More will greatly improve the lives of senior citizens?
Very good. Perfect. Very good. Very good. Thank you. Let me turn on the lights and we'll ask you some questions. Mrs. White?
Clearly you were inspired, and again, is the gentleman, he was a relative of one of yours?
No, he worked, go ahead.
He was a senior at the Merrill Gardens retiring community where my grandmother lives. And so he recently had a fall, and so that's how we got to him. And so he told us sort of his life and how he fell and things. I guess.
And so how did you come up with the idea of the boot? Why not a glove or a hat or something? What was it about the shoe that you said, this is it?
Well, we wanted to use something that seniors would use often. We also talked to some of our sensors experts, like Dr. McClellan, and he said it would need to be someplace where it would be easily able to see the ground. And so we mostly thought about glasses, belts, and shoes. And so belts, usually your shirt is going to be covering them, so that wouldn't work very well. And we decided that shoes, you're always going to be wearing shoes when you go out, so that would be the best way to.
When we were brainstorming, we had the ideas of shoes and glasses. Those were our two main ones. And at one of our practices, Claire and I sort of had a debate on which one we think would work better, and we had to figure out which one would be a better prototype and what would be better for an actual product. So for our actual product, we figured maybe both would be good. And for our prototype, this is a shoe we think would be better.
Let me peek at your sources. There we go. Okay, research lab visits, magazines. All right, good. Now, is when you did your research and you talked about what Nike is doing, is that really true? Is that what Nike's doing, or are you?
They are using it. In fact, I think I have it in my shoe right now, in my left shoe.
Very clever. No,
was very thorough.
Very, very thorough, very good job. You're very well presented.
Good. Thanks, you guys. Good luck today.
Yeah.
Thank you. Design is that we have one motor that runs 3 different attachments. And so we have a lifter on the back that we use to lift the weight and to catch the chair and to do several other things. We also have a carabiner hook that we use to catch the green medicine.
Oh, there's a urbanic catcher.
Yeah. And we bowl with this. If we go far enough down, it pops up and releases the ball.
Okay, so my favorite part about the robot is that we have a really cool quilt program. So what our quilt program does, we can demonstrate it.
Sure.
Okay. So what our quilt does is we have a certain lineup. We do it in between the 2 marks. So we set it up like that. This holds it together, but you can still take it off easily. So what we do is we push it, and then it ends up like that. But this is still on it, but it holds them together for us. And so when we do that, and then we come back and we get the flag. Okay.
Nothing is held down, by the way. So.
No,
Yeah, so you might want to
Yeah.
have someone hold things down.
Okay. So you want to run the quilt? Sure. We don't need to hold that one. So we have a beam on the front that's almost the exact same length as the quilts. So it's not a very intricate lineup, but it's about even, so we know how to line it up every time.
Oh, yeah. Whoops.
Yeah,
It wouldn't like that.
Right.
Oh.
Yeah, no. Yeah, there's a lot of problems with the
Yeah.
pieces we have right now. Well, that's cool.
So that's one of our programs. And then, do you want to run the weight program?
Okay,
So
so
have a ball.
We don't have a ball.
You're just going to this because we don't do that.
so I think this is our biggest program that does the most things for us.
How many things does it do?
So what it does, well, we have a green medicine one that we do before it, do you want to run the green medicine one?
Yeah, let's run the green medicine.
Okay. So what our green medicine one does is it looks for green. We have a color sensor on the side. So the color sensor looks for green, and then it sees green, and then we use our carabiner to grab it. It comes back to base.
We have four different sensors. We have 2 color sensors, a light sensor, and a touch sensor. That's robot.
That one's probably one of our most reliable programs. We get it almost every time.
I like how one motor can do this thing, and this. This is for the bulb, this is for the green medicine, and that's for
Okay. Make sure you.
So this is our weight program.
So we keep our color sensor out on the side to get one of these clicks. And then we wait till we see the green line. Oh, that's a new hit. Wow. Okay. Well, that's
Push it into place.
Good.
Yeah, our table's not flat. All right.
I think it's green.
So wait, so I'll keep it. It's
Here, why don't you, can you guys abort the program?
Yeah.
All right,
Okay, so-
just show us what it does.
so what it's doing is it's coming to get us. It turns and then it lifts the weight up,
Mm-hmm.
and then it turns. It backs into the wall to make sure we know where we are.
Mm-hmm.
And we go forward till we see 1 black line, 2 black lines.
Mm-hmm.
And we turn.
We back into the wall again. Oops.
And we go forward and we turn a little bit, and then we. Okay, you have to go pretty fast so that we don't.
Like that tip.
Gotcha.
Of course, we weren't lined up. So we.
Yeah, another thing we do is we back up into the wall twice, because sometimes when you back up, you're still not quite even, so we do
Right.
it again to make sure
Mhm.
that it's lined up.
Can we explain our programs to you?
I would love to hear you explain your program.
One in the pocket.
So our programs are pretty much all put into a bunch of my blocks to make them easier to read.
What is on my block?
A my block is going to take, if you say you want something to go forward, one rotation and beep. You can select those two, call it go forward and beep, and make it one block that you can just grab out.
Subroutine.
So you see
block.
this bowling? It says bowling. So that's a my block. So this is the bowling my block. So what it involves a bunch of other my blocks too. So we have a bunch of different my blocks, and then
We also have different parallel beams playing at the same time.
Mhm.
yeah. So
Mostly
we want to
for our line
follow,
following.
find the green line while you're also trying to lift the clip, or the
So
carabiner.
so your robot is performing all 3 of these tasks simultaneously.
Yes.
We have a pretty interesting line following block. And originally, well, basically it's a 5-beam line follower. And if it's seen in the middle of the line, meaning like half white and half black,
Mhm.
it will go straight. And if it sees a little bit to the left or the right, like 25% or 75%, it will turn a little bit. And if it's seen way off either side, it will turn a lot. And that way it stays a lot closer to the line. And basically how we do that is we look for it in ranges. So we look to see if the value is less than 20.
So it's a bunch of switches. So we see.
Yeah, well, it's
So we see, is it really low? Is it medium low? Is it in the middle? Is it medium high? Or is it really high?
so if it's not less than 20, the first block, it goes on to the next one.
Yeah.
So it goes on to the next, and if it's not less, then it goes on to the next until it finds the range where it's in.
So
This is some really sophisticated programming you
we've
guys
been
have
doing
got
this
going
for 3 or 4 years.
on. Okay.
So
Thank you.
to just explain one of our line followers, this was another one. So we had some issues with this one, but
I want to pause for a second and go back to the actual physical robot. How did you guys decide to go to a line follower that you're using 2 sensors for your line follower?
yeah.
No.
Oh,
No,
You're-
it's a color sensor and a light sensor. So the color
Oh, so
sensor
you're
is
using
looking at
either
green
one
light.
or the other?
Yeah.
in
So
all-
it's
Gotcha, okay, cool.
that's the parallel
So this,
line it's doing. It's following the black line and looking for the green line
So
at the same time.
I understand,
you
okay.
wanna okay.
So the light sensor.
So light sensor, color sensor.
Mhm.
So this was okay. So this was another line follower, but it wasn't as reproducible as our other new one. We had some problems because in this one you see that's a division block. So we were dividing it into different categories that didn't actually work.
We had problems with rounding, because it would round the value until, it would divide it by 20 and round it.
Round it to an integer? Or
Yes.
to a
It would come up with a value between like 0 and 5, and it was the same like 5-band program, but say you want it to go straight, you would have a value of 50, and so you get 2.5, and that rounds up to 3, which is the straight. So it goes, but if you get a 49, you'd still want it to go straight because that's pretty close,
Right.
but it will round down to 2. So we were having problems with that, so that's why we created our range blocks instead, which is a lot more
Gotcha.
accurate.
Do you want to explain some of these? These are some of our shorter my blocks.
Yes, but we only have 10 minutes with you, and I want to hit things other than programming, because you guys have a lot of really cool stuff. How did you manage to pack all of this onto your robot without switching? You guys don't have any extra attachments, do you?
Well,
No.
just the 2 things we use for the.
Well, the attachable things.
He's our master builder, so he came up with the
All right.
ideas.
I was sort of, it was sort of a trial and error, so I tried this one thing and see if it worked, and then until I found something that would work, and and we also changed it a little bit so it would work better with the ball, and we added this. And we did a little bit more stuff.
Yeah, at first we didn't have this on here, and then when we were trying the green medicine one, we needed something to capture that. So we made this carabiner and worked with the gears on here to make them all move at once.
Nice.
So, just in case you were wondering why we have these wheels floating in the air, it was because we didn't actually start having the carabiner on the robot. Like you said, we kept
Are they
adding more
your
things.
counterbalance?
So it's a counterbalance.
We had way too much stuff.
If you take them off, does it just flop right over?
No, but it affects our turns.
It makes the turn skid.
Yep.
We don't have
Like even
Yeah.
It's really,
And then the center of gravity is more this way.
Fantastic. I like your Omni wheel you have in the back there.
thank you.
See that?
It's nice because it can hold the weight. It holds the weight of the robot, but it can also turn and spin in different directions.
Yeah.
Yep.
So I don't know if you've seen any other robots. We tried this a couple years with the skidder wheel, but that was affecting our turns, and we had some problems with that in past years too, right?
Yes, it wouldn't always turn all the way, and that would affect which
This
way
is-
the robot goes.
this is like a skidder and a
Yeah.
wheel, so.
Right. It's real nice.
That's about all the time we have.
Yes, but thank you very much. I would be happy to hold on to that.
Thank you for your time.
No worries, it's our pleasure.
Yeah.
Do you guys have any more competitions today?
One more robot
What time?
right after this.
I think it's at 140.
All right, cool. Well, good luck.
Thank you.
Two, one, Lego!
We don't have any more time.
seconds.